Hello, thank you very much for joining us today for our webinar on high-performance Western blotting. We hope by the end of this, we have prepared you with the tools to see more signal with less noise. Today's webinar will cover the following topics: an introduction to Western blotting, 3 different Western blotting detection techniques, and how to design your high-performance Western blot. By the end of this training, you will understand 3 different Western blot detection techniques and the KPL products that enable them. They will also help you to perform your high-performance Western blot. We will begin with an introduction to the Western blotting process. You may ask, why would someone need to run a Western blot? Researchers run Western blots for a number of reasons. Examples include the following. There is a growing need to understand gene expression at the functional protein level. Researchers are making new discoveries that are driving new protein research, and they need exceptional sensitivity in order to further this. And Western blotting is an easy, well-understood application. You can confirm the identity and molecular weight of your target protein. It is low cost when compared to other technology, example, mass spectrometry. It allows for a simple comparative analysis of crude lysates and gives a clear way to visualize multiple sample treatments in one test. A Western blot is a means of separating a protein mixture by size electrophoresis in a polyacrylamide gel, followed by transfer or blotting onto a solid support membrane. These separated proteins may then be visualized by complexing them with a primary and secondary labeled antibody and then detected. Detection occurs using colorimetric or chemiluminescent substrates or via fluorescent conjugates. Step 1 is protein separation. Protein samples are mixed with loading buffer and loaded onto a denaturing SDS page gel. They are then subjected to size separation through electrophoresis. The next step involves the Western blot transfer. The separated proteins are transferred through a gel onto a membrane, either nitrocellulose, nylon, or PVDF, via electroblotting. After transfer, the membrane's nonspecific sites are blocked with a buffer. This buffer may or may not contain protein, depending on your system. The blot is then incubated first with a primary antibody and then with a secondary antibody conjugate for detection. Washing steps follow each antibody incubation. The conjugate is detected by addition of colorimetric or chemiluminescent substrate or directly if using a fluorescent conjugate. Here, we have a basic Western blot protocol, which illustrates what we just discussed. The lines in blue point out the different steps for which KPL has products that may assist you. We will now discuss 3 different Western blot detection methods and how we can help you make the best selection for your Western blot. The 3 main detection methods for Western blotting include the following: colorimetric detection, which utilizes color, chemiluminescent detection, which utilizes light, and fluorescent detection, and KPL has products that will allow you to easily perform each of these. The first technique we will discuss is colorimetric detection. It is an easy technique to perform as no special equipment is needed for development. Advantages include the following. The substrates involved are highly stable and easy to use. They allow for excellent signal to noise and are rather economical. Disadvantages, though, include that they are not as sensitive as chemiluminescent substrates. Your detection will be in the nanogram range. And they're also not as flexible as chemiluminescent substrates or fluorescent techniques. Once your color development occurs, it's difficult to amplify the signal or strip and reuse the blot. In conclusion, colorimetric detection would be ideal for those who do not require high sensitivity or do not have access to a darkroom or imaging system. Chemiluminescent detection allows for the following advantages. You are able to achieve the highest sensitivity possible, picogram to femtogram detection. Multiple exposures are possible, and your blots may be stripped and reprobed. Imaging systems will allow for real-time images, and the results are easy to scan if utilizing film. Disadvantages include that special equipment is necessary for visualization, either a darkroom or imaging system. The substrates tend to be more expensive than their colorimetric counterparts. and background or noise may be an issue. Chemiluminescent blots will require more optimization. Chemiluminescence is ideal for those who need the highest sensitivity possible or who would like to generate multiple exposures. Finally, we come to fluorescence detection. Fluorescence is best utilized by those who would like to capture real-time images, those who need to multiplex, and those who may be having issues with background. However, they will not be able to achieve the same sensitivity as you can with chemiluminescence, and you must have an imaging system in order to perform fluorescent Western blotting. Fluorescent detection will be ideal for those who like to multiplex and do not require high sensitivity in their detection. This slide here summarizes the 3 different detection methods we have just discussed and will be useful in helping you to decide your optimal Western blot detection method. We will now discuss high-performance Western blotting. Optimization of your Western blot will be essential when tackling high-performance Western blotting. Superior signal-to-noise requires the balance of several elements, including antibody specificity, effective blocking, effective washing, and your optimal detection system. All of these pieces need to work well together in order to obtain the ultimate Western blot. There are many factors to consider when optimizing your Western. It is essential to have excellent specificity to your target. This is largely a result of specific primary antibodies and will be enhanced by the proper choice of secondary antibody. Sensitivity will be a combination of your chosen tag and substrate system. Background is an area that many Western blot users struggle with. It may be defined as nonspecific signal that diminishes contrast, thus decreasing the ability to see your desired signal. Background needs to be low for optimal contrast of signal to noise. Selecting a specific antibody will allow for fewer problems with nonspecific binding. Choosing the optimal block solution and diluent will help to block nonspecific reaction sites on both the target protein and the membrane. And wash solutions will help remove unbound antibodies, all of which may contribute to excess background. Many of the issues with blocking center around the use of non-fat dry milk powder. It will work well with certain Western blot applications, but generally does not do well with high-performance Western blotting. There are 4 classes of blockers we will discuss today: milk-based blockers, serum-based blockers, non-mammalian blockers, which may be combined with mammalian components to enhance the blocking capabilities, and non-protein blockers, the latest addition to the Western blotting foray. KPL has all the blocker classes covered. When thinking about blockers, consider using airline seating arrangements as a way to remember them. Protein-free blockers are going to be first class. Our new blocker, SignaLOCK, will provide ultimate detection when paired with premium substrates. There will be no cross-reactivity issues with antibodies and conjugates, and it is crystal clear. Non-mammalian blockers will be next in business class. Our 5X detector block, which is a unique 2-component system that utilizes fish gelatin to limit cross-reactivity, non-mammalian protein. This blocker allows for excellent signal-to-noise. Economy Plus will be your serum-based blockers, including KPL's 10% BSA diluent block. It is compatible with most detection systems and allows for acceptable signal-to-noise. Economy Class will be your milk-based blocker. While milk is the industry standard, it is not recommended for high-performance Western blotting. However, KPL does assist in making block easier to use with other types of Western blotting by producing a liquid formulation that will allow for lot-to-lot consistency. KPL also helps you take the work out of washing. We supply easily dilutable concentrates, so there's no need to prepare buffers in your lab. We have a wide variety of formulations to help meet your needs. Our 20X wash solution is our premier choice for Western blotting. It is an imidazole tween 20 formulation. It's optimized to enhance signal-to-noise benefits and works well in all systems. We also offer generic wash solutions as well, including 10X PBS and PBST, and 10X TBS and TBST. We understand as a Western blot user you are always interested in how much more signal you may see. Selection of your optimal detection method will depend on the amount of target present. Many options have become available as the Western blot detection science has developed over the last 30 years, and we have products for all detection options. The most accepted process for Western blot detection is enzymatic detection. There are two main enzymes used for this process: horseradish peroxidase, or HRP, and alkaline phosphatase, or AP. KPL offers an excellent variety of substrates for both colorimetric and chemiluminescent detection with both enzymes. We will now discuss the enzymes that drive Western blotting, AP and HRP. This table here illustrates the differences between the two enzymes. AP will give you slower kinetics and allow for better control of the reaction. However, HRP with faster kinetics will give quicker results. Signal duration will be longer with AP, up to 5 days in some cases, while HRP is shorter. However, you'll see that there are more choices for HRP, primarily due to sensitivity and price, thus resulting in its increased popularity. KPL offers a wide variety of choices of substrate for HRP and AP colorimetric detection. Our TMB membrane is going to offer the greatest sensitivity and colorimetric detection, high picogram, while 4CN offers detection in the nanogram range. For AP, we have BSIP-NBT and FirePhos membrane. Both will give detection in the lower nanogram range. Many of these substrates are ready to use and would be perfect for automation, including TMB membrane, BSIP-NBT, and FirePhos. In addition to colorimetric, chemiluminescent choices abound. For HRP, we offer LumiGlow and LumiGlow Reserve and LumiGlow Ultra. For alkaline phosphatase, we offer PhosphaGlow and PhosphaGlow Reserve. LumiGlow Ultra is our newest offering. We also offer products for fluorescence detection. It is good for those who want to multiplex, have access to an imager, or who have an abundance of protein. There are no issues with enzyme cross-reactivity. KPL offers many choices for detection, with 13 fluorophores available, with emission spectra ranging from 405 nanometers to 800 nanometers. We will now begin further discussion on our HRP chemiluminescent kits. KPL has taken the time to develop exceptional substrates and present them to you in optimized kits. This will allow for less optimization by the researcher. You can get your results done quicker and faster. We offer different Western blots for different levels of performance. You'll have your tried and true workhorse kits, kits that work in multiple situations, and kits when you need the utmost in performance. What you will see from our kit lineup is the following. On the left, with our protein detector LumiGlow Western blot kit, you have your standard family car. It is reliable. It will get done what you need to do. This will be your workhorse substrate. It will give you sensitivity in the picogram range, will be stable for at least a year, and is less expensive when compared to its high-performance counterparts. It is a good substitute for ECL and West Pico. Shifting to the middle, you will see one of our new product offering, our SignaLOCK HRP ChemiWestern kit for imager. And as demonstrated by the off-road truck above, sometimes you need ultra-sensitive detection for your system. This is going to be your performance chemiluminescent substrate kit for imagers. It will give you femtogram detection, and it is a good replacement for ECL+, ECL Prime, and Westura. And finally, to the right, you will find our race car kits, SignaLOCK HRP ChemiWestern kit for film. This will give you exceptional performance on film with femtogram detection and will outperform both ECL Prime and West Femto. This slide here presents all of the kit components for these kits. As you see, whether you need a workhorse kit, a specialty product, or high performance, KPL offers it all. Your protein detector LumiGlow Western blot kit users are looking for good sensitivity. They need picogram detection, bands that can be observed within 1 minute with optimal sensitivity in 10 minutes, and blots that may glow for at least 90. These are the customers who need an economical choice and may be seeking versatility. It may be used on film and CCD cameras. For use on a CCD camera, it will need to be a newer camera that allows for exceptional sensitivity. Your specialty users, your SignaLOCK HRP ChemiWestern blot users, are looking for maximum sensitivity and quick time for results. They need femtogram detection. They want the results in a minute. They may also be looking for long glow time with HRP. They'll be willing to pay a premium for results and are using imagers. Your high-performance users for SignaLOCK HRP ChemiWestern blot kit for film are seeking exceptional sensitivity. They need femtogram detection on film. They results in minutes of the application of substrate, and the blots may glow for up to 8 hours. They too will be willing to pay for a premium for results and will be film or darkroom users. KPL also offers an AP chemiluminescent detection kit. This kit is our SignaLOCK AP ChemiWestern blot kit, which may be used on both film and imagers. It allows for femtogram detection, and it will glow for up to 5 days. It's going to be an excellent substitute for CDP Star and LumiFos. And as you see, this kit comes with our SignaLOCK blocker, 20x wash solution, and substrate. These users are seeking an AP detection system. They may need excellent sensitivity and extended glow time. They're also looking for a detection system that works with both film and imagers, and they may need a ready-to-use substrate formulation, which PhosphoGlow Reserve will give them. We have covered quite a bit today, including the following. We have discussed the pros and cons of the 3 main Western blot detection techniques, including colorimetric, chemiluminescence, and fluorescence detection. We have explained that high-performance Western blots are a result of optimizing your conditions, your antibody specificity, your blocking conditions, and we have presented 4 different types of blockers for you to choose from, your washing, and appropriate selection of your detection system. HRP chemiluminescent kits will give the most sensitive detection in the quickest amount of time. Kit lineup includes our basic detection, or LumiGlow, to high-performance detection on imagers with LumiGlow Ultra, and film with LumiGlow Reserve. Our AP chemiluminescent kit offers high sensitivity and extended glow time. PhosphoGlow Reserve offers this exceptional sensitivity, and ready-to-use reagents make them suitable for high-throughput systems. KPL offers quite a bit of Western blot support material, including different brochures and flyers for each product and application notes. We also offer technical services. You may find all of this information at www.kpl.com. Thank you very much for attending our webinar today. We hope you have learned a lot. Please contact us if you have any questions. Thank you.